space and intelligence from a mostly experiential perspective. The reason why I like to start with this slide, which is a snippet from an Aphex Twin video, is because it allows to reimagine urban space through a series of algorithms that are about manipulating the visual as well as spatial quality of that environment. So I think a lot of my talk is going to be stressing that relationship about how we work with machines, how we work with tools, technological tools, in order to create space, not only as a means to construct space physically, but also as a method to experience space in a different way. So I started my architecture career about 15 years ago in Frank Gehry's office. And the project that I was primarily responsible for is this museum that you're seeing in the video, which is for the LVMH Foundation in Paris. At the time, for those of you that are familiar with Frank Gehry's work, he has a very distinct personal style that is very much so unique to him and his experience. And the technological relationship, I would say, between a design practice like his and the world of construction was primarily focused on this notion of spatial complexity and how we could build very complex buildings, how we could take an imaginary vision and turn it into reality. And so therefore, if you look at the tools that were created around that time, starting with Disney Concert Hall, moving onward, you're looking into parametric design tools, which are geared towards speeding up the design process, but also streamlining the relationship between what is in the computer versus what is going to be built, so that there's less of a negotiation that happens between what's in the computer, what's in before your eyes, versus what's on the site. And I think we have a very different type of approach about utilization of technology for design now. I think we are moving away from buildings that are built with technology into a realm where we interpret buildings as technology. And I think that is a very different kind of approach. Or the reverse is also applicable in the sense that technology is a building, in the sense that it creates worlds, it creates environments. And therefore, we no longer can view technology as a subservient tool for creating objects or spaces, but in fact, the kind of philosophical impact and the social impact of technology is something that forms the way we interact with the world. And I think that has also influenced a lot of the different kinds of approaches in my own work. Currently, I have my own architecture firm. I also teach at UCLA. I run a research lab, and I have a group of grad students, and we focus on basically some of the new cutting-edge technologies and how they relate to design in the production of experiences, as well as in the experiences themselves. For example, we focus on robotics, we focus on virtual reality and augmented reality, we focus on machine learning, and a lot of these things happen in the form of pure experimentation, and then they get distilled into some kind of realistic application as it becomes a way in which we can take that research and turn it into a real accessible experience for people. So I will start talking about what we do in the Ideas Lab at UCLA. Currently, as I said before, based on this notion of thinking about environments that are technologically enhanced rather than thinking about environments that are built by technology, we are primarily focused on human-robot interaction and how we can envision environments as robots rather than thinking about environments that are built by robots. And I think that is a very important distinction because it really allows us to integrate a lot of these technologies into the buildings themselves. And in order to be able to do that, we have to create workflows so that we have a more human-centric approach about how a potential building can, let's say, change its form according to its inhabitants, rather than the building constantly enforcing the way in which we occupy that space. Obviously, there are plenty of bottlenecks in this process, which I will talk about in a little bit. But I think what is exciting for us is that, especially in a design context, in an architecture context, we have had the opportunity to be able to create highly complicated, to address highly complicated technological problems in very cheap ways. The video that you're seeing right now is us controlling our industrial robots real time with virtual reality controllers and headsets. For example, the reason why we need something like this is we attach large-scale architectural panels on top of these industrial robots, and we simulate environments that are in motion. We simulate environments that can change their shape. We simulate environments that can reconfigure themselves. And then we can test the impact of these transformations real time. And in order to be able to do this very quickly and cheaply, this kind of a virtual reality controller workflow really allows us to address some of these technological problems in a very quick way. Another thing that is important about this is that in the world of design and architecture, what is starting to happen is that we are starting to move away from designing forms into designing experiences. And I think that is a very interesting paradigm shift. So instead of working with a kind of a formal language of forms that could be the signature style of an architect or a designer, we are starting to think about how the environment can behave in a particular context, in a particular social context, climate context, you name it. And in order to do that, we create a kind of a gaming engine-centric design approach rather than a 3D modeling-centric design approach. And again, that is a big paradigm shift in the sense that if the 90s in the world of design was defined by 3D modeling, I would claim that our time is going to be defined by gaming engines. Because in gaming engines, you can create simulation, you can create relationships between objects, you can predict and set up a scene and allow the whole ecosystem itself to virtually unfold before your eyes. So you can actually have a much more projective approach towards design rather than a conclusive one. And I think that is a very different kind of philosophical difference in the sense that it conflicts with thousands of years of architectural knowledge because we always expect buildings to be lasting as long as they need to be, right? You know, when we look at the pyramids, some of the biggest cultural monuments that we have are always based on this notion of permanence. But change always requires temporality. Change requires transformation. Change requires agility. So I would say that there's a fundamental conflict in architecture and the way in which we build spaces versus the way that we currently live. And the reason why I'm talking about this is because we, in a way, maybe need to open the definition of architecture and not limit it so much by only on the practice of construction, but think about it as a way in which we experience different sorts of environments. So a virtual reality scene should also be considered as architecture, especially if we're going to be spending exceedingly more time in these kinds of virtual environments. one of the reasons why I'm talking about this is because we always, you know, in the last few years, we talk about Industry 4.0, Fourth Industrial Revolution. And what is, in a way, I think misleading about this is that we always focus on the problem of automation. But I think what is interesting and different about our current time is awareness, in the sense that inanimate objects start becoming aware of their surroundings. And that is a highly architectural problem. A sensor embedded environment, like a factory floor, is now becoming a highly architectural problem. But it's a form of data architecture that allows you to define environments and spaces and parameters and boundaries, and how those boundaries in a way relate to each other, again, is a highly spatial problem. Currently, that problem is primarily addressed as an engineering challenge. But the actual, I would say, essence of that problem is a design challenge. So it requires a different kind of thinking, a spatial thinking, that streamlines a lot of technological issues that engineers face in the field. And when I talk about engineers, I'm talking about everybody ranging from an industrial engineer that is responsible for designing a factory floor to a software engineer that needs to develop the so-called virtual architecture of that environment and what have you. So for me, this notion of temporality primarily exists due to the relationship between media and space. I think we currently, as we veer away from physical forms of media into digital media in the last 2 decades or so, that influences generally our relationship and our approach towards objects, and how eventually we create environments and spaces through architecture. So this, as we talk about the new parameters of architecture, I would say that the new parameters of architecture are presence and action, in the sense that you have to be present physically and virtually in a space. You know, we all are, in the sense that if you have a cell phone, your location is tagged. There are certain other parameters that are relating to geofencing. Some kinds of actions happen without you even seeing them. They happen virtually as data transfers happen. And then you can take action against these things, right? There's a kind of an overlay of a virtual world into a physical world. Sometimes they intersect, sometimes they don't. And that relationship is the very relationship that is incredibly problematic right now. And I think that's what the attention of most engineers and designers need to go into, because that is a fundamental problem that relates to, in a way, media and space. What I mean by media is a sort of experiential manifestation of data. It's the form of data that we can see, right? If you see a moving image as media, that is data. That is like pixels, that is basically communicating a type of information to you that can be interpreted and understood through your senses. So in that regard, I think the new form of architecture at this point in 21st century is one that relates to this very dynamic relationship between media and space. And the way that we are investigating that in the lab at UCLA, and as well as in my firm, is through looking at the applicability of some of the emerging technologies. So I think all in all, it always comes down to the problem of telepresence, because telepresence is this moment where you will be able to access both digital and physical worlds at the same time. You can be present in a location that you're not physically. And in a way, it's all about this notion of communication. So if we're looking at it as a form of full virtual simulation, we can talk about VR, AR, basically extended reality. And then if we're looking at it in a kind of a more cyber-physical way, Then we're looking at robotic fabrication, sensor interaction. And obviously, both of these kind of hardware platforms, as they interface with humans or other objects in the real world, require a series of software contexts in order to produce the framework of the work. So obviously, AI and machine learning is becoming an emergent subject in this. Procedural modeling, setting up relationships between forms, so allowing more agency to the computer to iterate the design. And also, obviously, standard modes of coding and programming so that different types of hardware and software can interface with each other. I mean, obviously, I don't pretend to be an engineer or I don't write software, but what we do is mostly in the context of looking at what's available strategically and how can we interface different things together in ways in which the a kind of a product development process cannot. Because I think ultimately what an architect does is always looking at the bigger picture and figuring out ways in which different elements of life can interface with each other and come together. But going back to my initial topic, spatial intelligence, I think there are two components of that for architecture and design. One of them is spatial intelligence as a form of interactivity, and the other one is about developing generative tools that can help you design. I think those are two different forms of intelligence. One requires an understanding of how a person is going to occupy that space, and another one is about how a designer can collaborate with new technologies and machines in order to create and optimize different forms of design. What is interesting to me about this process right now is that the tools are the same to be able to do both. And that refers back to my comment about gaming engines, because in the same tool, not only that you can create a set of procedural modeling processes, but you can also establish relationships between different kinds of technological objects. For example, you can create a highly complex particle system, which could be the visual backbone of your new kind of environmental application in the form of, let's say, an art installation. And in the same software, you can also integrate your sensors, and those sensors would be able to allow you to control that particle system interactively. So I think having this kind of a continuity between the digital and the virtual as a tool is incredibly important. So I will start with the interactive, because that is something that we have been working on for a while now. This installation that we did in our office called Cerebral Hut was a project 5 years ago. And it was the first architectural environment that changes its shape physically through a brain-computer interface. As you can see, there's an electromechanical system that is embedded into the physical environment, and that is interacting with an EEG headset that the audience, one of the audience members wear. And through a series of negotiations, software negotiations that happen in the computer, the environment can physically change its shape based on certain kind of thought patterns. So you can look at a particular panel. The EEG headset has an ability to detect whether you're looking left or right. And it also has an ability to understand when you're concentrating. So when you're looking at a panel and you're wanting it to move, you're paying a lot of attention to that particular zone. And that zone is activated and it starts moving. So obviously, this is the ideal scenario. None of these technologies work as this level of Jedi activation. Nevertheless, I think it is an important polemic to understand and establish a new kind of relationship between architecture and environments in a world where the body itself is not the only perpetrator of change in a physical environment anymore. And I think that is something that is very new. And this happens through, obviously, sensors and other forms of interfaces that allow us to create bridges between one type of intelligence with another one. And without it, obviously, we wouldn't be able to do it. But I think what is important to know is that, or what is important to understand is that we are starting a time where the body no longer has the significance or the kind of untouchability, so to say, as it had for like centuries and centuries. And I think that is a very interesting and very problematic time in that regard, but I think it also opens up a lot of possibilities. Another example that I want to show about interactive spaces is this augmented reality intervention we did at the Venice Architecture Biennale 5 years ago. It was one of the first implementations of augmented reality in an art and architecture context. And the purpose of it was to, in a way, hack an existing cultural system with another one. There was an existing physical exhibition, and me and my team went in there and we installed a virtual exhibition that is embedded inside the physical exhibition. So you could download the app and you could point your camera, obviously, through a treasure map that was given to you in the app. And you could unravel all these virtual exhibits that are embedded and coexisting with the physical exhibits through your cell phone or your tablet. And I think what is interesting about this is that, or the issue that it brings up is that we can start developing a new kind of design paradigm where a part of design could exist physically and another part of it could exist virtually or in the form of media, and it has to be in a way envisioned simultaneously. We cannot think about media applications like augmented reality or projection mapping or any of that sort as a kind of an applique anymore. We have to think about it as a fundamental part of the design. And in a way, it needs to start influencing the design process from the very conceptualization phase. And based on this paradigm, we pitched a pavilion for Coachella last year. And the idea behind the pavilion was that there would be a static architecture, and then there would be a dynamic architecture that is moved through robots. And then there would be a virtual architecture that is interfacing with the physical architecture through animation and the media content. So in a way, this set up the stage for this kind of paradigm that we're defining as cyber-physical architecture, in the sense that there's a physical static component, there's a series of dynamic components, and there's a series of virtual components that are all designed in conjunction with each other in order to create the affect that is this new type of cyber-physical architecture. So what would happen in this pavilion is that you could text the pavilion and tell the pavilion what set you want to see. And then the pavilion would text you back saying, I will show it to you in purple. And the moment it turns purple, you would have to follow the wings of the pavilion to point you in the direction that you would want to go. So that you could have this more dynamic relationship. And I think this is where it ties really well into gaming engines, because then you start designing architecture as a character. It becomes a personality that you interact with. It becomes a kind of an actor in a scene that you would be able to establish a kind of a dialogue with. This kind of work, in a way, we have explored it in many ways in the lab at UCLA. The video that you're seeing on the upper left is a large-scale folding physical panel that we attached to our industrial robot. And the other robot is holding a video projector. And the whole system is controlled by a sensor that detects your hand gestures. So based on your hand gestures, you can change the physical shape of this wall, as well as the virtual content that is being projected on top of the wall. So it allows you to manipulate an environment through a series of sensor interfaces based on your liking. A similar kind of application is happening in the red project right next to it. It's again a prototypical wall panel that detects your presence and comes towards you. And when you touch it, it changes color, so that you start establishing a different kind of tactile relationship with architecture. And a series of other machine vision projects that primarily relate to fabrication of different architectural components. But I think what is, going back to the problem of VR, what I think is fundamentally interesting about VR is the notion of scale. In architecture, you always have to determine scale, and through a series of plays in scale, you create architecture. I think this ties nicely to the conversation in the previous presentation, because you create a network of different scales of voids in order for humans to occupy. That's, at the end of the day, what architecture is. If you go to a really well-designed building, those voids are very well choreographed. Sometimes you have a very narrow space, and then you walk through that space and you go into a really large atrium. And once they exist, let's say, in contrast to each other, it creates a sort of architectural drama. And that drama and that play of scale allows you to sequence a series of experiences for people to have once they visit a building that you designed. But again, going back to the problem of scale, what if in the world of VR you have no scale, right? You can start experiencing something as an object, and then you can scale it up and it can become an environment, or it can be something in the scale of a furniture. So you can address, through the same design language, 3 different problems of design, which is again, something that is very threatening to architects, right? Because architects would like to really control and refine scale. That's one of the skills of architects. That's what architects are really kind of trained for. And when you can say, oh, here's an object, whoop, I turned it into a sphere, it exists fundamentally in opposition to many of the principles of architectural design. But it also presents an incredible opportunity, because it allows you to, in a way, sequence a series of experiences, and you can regulate the access and the experience through scale, which all of a sudden it becomes an interface problem rather than an architecture problem. Or you can use virtual environments to create enclosure. You know, obviously this was a project that we did pre-Tiltbrush, although Tiltbrush is mostly creating sculptural scale objects. What we tried to do here is this enclosure generator based on a series of palettes. So instead of different brush strokes, you have different architectural features. And you can paint a world around you and design and prototype it real time in a virtual environment. I think another important thing that I think is relevant, which was something that I talked about, was this notion of thinking about architecture as a robot. So I asked my students to create a series of responsive architectural physical models that would be able to change their shape through a sensor interface. What comes out of this is a series of forms that are designed to transform, which is again existing in opposition to the very static notion of architecture, that architecture needs to be fixed, that it needs to stay, that it needs to be stationary, it needs to be here for decades or hundreds of years ideally, right? So I think this challenge that that the virtuality poses towards architecture is also an incredible opportunity, because it allows us to, I would say, create environments more sustainably. What if we could allow environments to be able to evolve and change according to human occupation? What if they could basically limit their resources when there's less occupation, use more resources when there's more people in it? Or if there's a way in which it could expand and contract so that it could change the type of presence that it has in the urban scale. What if we could do that? Or what if we can take an inherently virtual structure and bring it into a physical world? So this is what we did with this pilot study that we did, where we took social media environments and created physical interfaces in order to interact with them. So in that regard, then, how do we access different types of information in a particular virtual platform in the real world? Moving on to generative. Primarily, if we think about generative, we can think about it as a way to generate architectural form, but we can also think about it as a way to generate enclosure. The first generative project that we proposed in the office was this pavilion that we designed for an electronic music producer. It is made up of these self-similar crystalline shapes that are assembled and disassembled by a series of industrial robots. And the idea behind that was that there would be a computer interface that would take the music being produced by the composer and turn it into a series of Cartesian coordinates, and allow the robots to assemble and disassemble them as in real time, based on the data being translated from sonic into spatial. So this, in a way, kind of becomes this performative act of architecture, constantly evolving before the very eyes of the audience as a backdrop to a musical performance. So in this system, I think what is important to consider is that the architecture is generated real time, that there's no final form to that architecture. There is no actual optimized goal to that architecture, that it has an ability to assemble and disassemble itself constantly in real time to a different type of artistic medium. So this notion of temporality, as I think, is very relevant, especially when we talk about it in the world of 3D printing. So based on this real-time robot control technology that we prototyped, we entered a competition that was hosted by NASA to design the first human habitat on Mars for 4 astronauts. And that was, we were tied for the 3rd place in that competition. And what I think is important about this is that our goal was to develop an architectural system that could be fabricated through the indigenous materials on Mars autonomously. So you would send a bunch of robots to Mars. They would collect, grind, and heat and fiber basalt, which is a very abundant type of rock. Every time you see a gray area instead of red on Mars surface, that's basalt. And when you go into a car and they tell you that it has carbon fiber inlets, it's actually basalt because it's cheaper and it looks exactly like carbon fiber. It has similar mechanical properties as carbon fiber as well. So, you know, what is interesting about building scale 3D printing and really problematic to me is that every time we see some kind of nozzle that is attached to a large scale industrial robot and they extrude the most primitive materials that we can imagine, they try to make these concrete puddles or piles or something that create these cave-like structures, but if we look at the construction industry now, it is much more sophisticated. The materials are much more sophisticated. The technologies of production are much more sophisticated. So we wanted to tackle that problem. How can we create high-performance enclosures? How can we create something like a spaceship? Something that has the properties of a spaceship rather than sending a bunch of people on Mars and putting them into caves. So I think there's something fundamentally problematic about that logic. So we were looking at how spaceships are built. You know, they're usually built with like really lightweight materials, and they're very sturdy materials. And they're usually built with some kind of metal or composite material like carbon fiber, and they're treated with ceramics so that they can resist the heat, right? Or large temperature fluctuations. So based on this logic, we were thinking that we would create a series of woven fabrics and sleeves out of basalt fiber and mix it with a UV activated resin. So if you think about a carbon fiber layer on a boat, you have the fabric and then it's soaked in resin, and then it's either bagged or it is dried outside, and it stiffens as it bonds with the resin, right? So if we bond it with a UV curing resin, which is something that you would use on your surfboard or something, so you expose it to UV light. There is plenty of UV light on Mars because there's no atmosphere. So the moment that you soak this thing with UV curing resin, you create an instance where you can 3D print in midair, real time, with a series of woven fabrics. So they really liked the fabrication method and the white paper related to it. They didn't like the architecture, which was, which is, I think, sometimes getting over this kind of cultural barrier is more problematic than getting over a technological problem. So in order to communicate to them what the architecture would look like, we created this VR simulation. And the way that we talked about it was that you think about sending 4 humans on Mars. And everybody in the world would be watching them. Their lives are probably going to be broadcasted like a reality show. We're probably going to be, going into some website and going like, let's see what astronaut Jennifer is doing today and what happened between her and so-and-so. And in order to, create this context and in order to have continued public support, we need to capture people's imagination. Some of our most important institutions are built with very bold architecture. So why would we want our astronauts on Mars to live in canisters? So we want something that would actually be able to even capture the children's imagination if we want that sort of support to continue for a project like this. So we created also the interior, and we launched this thing as a small video game where you're the astronaut just landed late, and you have to go around and reset a bunch of 3D printing robots, and they give you information about what how to fix them, and then you go inside and then you brief the team leader about how you fix the robots on the outside. Based on, oops, crash. I'm almost done. Okay, here we go. So I would say that that is something that is relating to creating something physical. But also something generative could be not about just building up new materials, but also collaborating with other machines. So there's obviously, I'm sure many of you are aware of the contemporary trend about creating images through neural network algorithms, right? So there's a lot of people that claim to be artists that are doing this sort of work. And there's this huge controversy about the relationship between agency, like who actually owns the work, because all of these algorithms are created by corporations and the artists are just using them, but sometimes the engineers that create them want to claim agency over the artwork. So there's a huge mess right now in the art world about what is happening with algorithms and what is the image, what is the quality of the, or the status of the image that they create. So in order to tackle this problem, we went exactly in the opposite direction. We said, there's only one culture. If you think about a way a DJ works, they take different songs, sample them, play them real time, and create a soundscape for people to enjoy, right? So what if we did that in the world of art and architecture and really own these influences? And what if we allowed the machine to help us sample and make sense of these different kinds of influences? So we created this machine learning interface where you pick your influences. You can upload a picture of a dress, a painting, a sculpture, a pattern, and then you can give it different weights. And in order to do this for architecture, what we did was we picked 5 buildings in downtown LA so that their urban address was already done, in the sense that we didn't have to force the students to look into relationships of massing and adjacency and how a building is configured, but just looking at the envelope. So they would create different machine learning iterations about how they want these different types of influences to affect the envelope of the building. And once they did that, they had to do a reverse engineering process where they interpret the image and 3D model it as accurately as possible based on what the machine created, and then install it back into a drone footage that makes it look like that building is completely transformed. So in this process, I think what is incredibly useful is that you start creating architectural languages, formal languages, that you would never be able to come up with your own. And in a way, you are sampling different kinds of cultural influences that are external to architecture. And you allow for this kind of more disciplinary system to emerge through using machine learning as a tool. And I think what is interesting about these interpretations is that, did the machine created, did the human created? It's all human work. A human wrote that algorithm, so there's no point at this point in history to talk about who owns the work. But I think what we need to do is we need to look at other people's creativity in other fields more attentively and allow the technology to help us with creating more cross-disciplinary collaborations between different agents. I'm going to skip this project because I don't have time. Maybe I will skip this one too. And I want to end my presentation with this project, which is called Cypher. It, in a way, I think exemplifies a lot of the issues that I was addressing in my talk. Cypher is an interactive silicon sculpture that is roughly around this tall. And it is made up of hundreds of different components that range from just a very, aesthetic to highly robotic. It's made up of these clusters that are activated through infrared sensors, and they inflate and deflate according to the position of the audience around them. It also has a LiDAR sensor on top of it that allows it to understand this environment, so it can distinguish between a person, a wall, and a cat, and it will only interact with humans. And when a human approaches this sculpture in a very close way, it starts to pulsate. When you walk around it, it changes its entire mass in order to respond to you. But these are the interactions that you will have in the physical sense. So what happens in the interior? Cypher also has a tail. At the end of this tail, there is a virtual reality headset. The moment you put on the virtual reality headset, you're teleported inside the sculpture as if you're a small person in it. So all of a sudden, the thing that you experienced as an object becomes an environment. So it creates this dynamic relationship between sculpture and architecture. So once you put the helmet on, the helmet indicates to the world that the VR scene is activated. The sculpture turns into a virtual one as well as your body. And once you go inside, you can manipulate this VR scene with the controllers, which changes the shape of the sculpture real time. So when you're moving the sculpture, when you're moving the environment in the inside, you're moving the sculpture on the outside. So people can track where you are inside the sculpture by just looking at the sculpture. So this radical shift of scale allows you to create a very dynamic relationship between objects and architecture, right? Something that is an object all of a sudden becomes architecture. Something that is architecture all of a sudden becomes object. So this notion of representation is no longer applicable thanks to this technological bridge. And I think we are, just to wrap it up, at a time when, just to tie it to the theme of what we are talking about today, is that a fictional narrative becomes an experiential reality through a technological interface. And I think that is really hard for architects and designers, people in the business of creating objects, to understand. Nevertheless, I think the technologists have a much better view of this. And I think it creates very interesting and engaging conversations about what we consider to be a form of reality. To me, reality is anything that is experiential, just like anything that is experiential is architectural. Thank you.
We have time for a couple questions, but please use the mics if you do have a question.
Are there historical examples of buildings that dynamically reconfigure themselves for the use case that we can draw on for metaphor?
This has been actually a kind of a long-time fantasy of a lot of avant-garde architects. If you look at the work of many architects from the 70s, there's this group called Archigram, for example. They created this series of projects called Walking Cities. I mean, obviously, they were all utopian, and it's only done through illustration. But if you want like a real example, there are multiple auditorium-type environments that change their shape, right? And then there are also buildings that respond to the climate on their skin in a very kind of a low-level way. But the kind of transformation that I'm talking about is obviously mostly happening in a scale of installation or proof of concept at this point. But I think that is going to change dramatically in the near future.
I'm curious, so it's interesting how you're proposing a new type of experiential architecture, which is different from what I understand from my own architectural background as being the historical association between experiential architecture and phenomenology, where experiential buildings are correlated with permanence and emphasis on craft and construction and tools and the whole paradigm of the impact of natural light shining on exposed concrete, etc. So has that kind of historical legacy been a source of resistance in terms of developing your ideas?
For sure, in the sense that to me, it's more of a reality check. There are many things that I love about architectural materials. There are many things that I love about the tradition of architecture. But I feel like if architects and designers stick to these very fundamental concepts of architecture, they're going to be rendered irrelevant. So in my mind, this is more of a survival game. And also it is something that, you know, I think is going to be detriment to society, in the sense that architects are the people that know how to design spaces the best way, right? Because they have that kind of training and experience. So we have to figure out a way to apply that into other types of experiences that are not exclusively physical. So I see this as a void, so to say, that needs to be filled. And I think it's a very important one, because we are at a point where two-dimensional interfaces are starting to transform into three-dimensional spatial environments. And we have to figure out a way to collaboratively write the design rules for that, right? So that's, in a way, what I'm hoping to accomplish. You know, there will, in our lifetime at least, I would imagine, there will always be physical environments that we will be inhabiting. But if we cannot figure out a way to superimpose, integrate virtual content in a meaningful way, I think it becomes more and more isolating and lonely. I think one of the biggest problems with the internet is because of the interfaces in which we're accessing that information, because they're inherently two-dimensional. They're inherently antisocial. They require your attention only in a very fixed, narrow fragment of the physical world, right? The screen, it doesn't matter how big your screen is, it's only a very small fraction of the actual world that we live in. So once things become spatial, I think they're going to become much more social. And once they become more social, I think a lot of these issues that we are facing about internet and social media and what have you, maybe they're going to transform into other problems, but they're not going to be the problems that we have right now.
I've had the experience of being in different kinds of architectures and having psychological or emotional or even visceral responses to the architecture, and this is very well established in architecture. I also imagine that as soon as there is a feedback between a person and a very familiar space, maybe a living space, and where the architecture of that space becomes modulated based on the person's experience, whether it's emotional or tactile, that there's a kind of that there's this feedback that takes place. Can you talk at all about the experiences of the people who have these structures that feed back onto their environment based on the person's interface and changing of the structures? So what's it like on an emotional or psychological or visceral level to be in a very familiar structure and then have it alter based on, say, your readings of the EEG headset?
I think fundamentally what happens is that since, you know, everything in life is based on motion, right? There's always something moving in the world. In many cases, we are the ones that are moving, right? We're in a car, or we're in a building, we're in different rooms of a building. So our sensory makeup is designed to constantly process change, you know, and measure change, quantify it, and put in a bunch of mechanisms for us to understand and process and respond to that change, right? Like the reflexes would be like an extreme example of that. Like if an object is coming at you, you duck, and then, you know, that it's some physical parameter, it suddenly and extremely changed in your context, so you're responding to it, right? So I think it is in a way, a similar type of processing that would happen when a physical environment changes according to a bunch of different parameters. I think in a way, obviously I haven't done a study on it, so I wouldn't be able to give you any information about that, but I think the fact that we can handle it is based on our evolutionary makeup, because we're always geared towards understanding and responding to change and motion. And one thing that is always static is architecture. Even like nature changes all the time, right? So we expect our artificial structures to remain static and preserve themselves forever. But everything in the world changes. So to me, there's this bizarre problem about the way in which we set our expectations from architecture. Like when the Notre Dame burned, right? Like a few months ago. A historical structure, obviously we love it. Everybody associates Paris with it. But, you know, how can we envision our cities and our environments to be these permanent places that are so resistant and so unflexible to change and transformation, right? I think that is in a way something that I'm trying to explore both conceptually in a productive way, but also in a provocative way, in order to question some of our fundamental notions about what we consider to be a legible, culturally significant example of the built environment.
Why do you think this concept of like spatial thinking isn't more prevalent on the internet? Like, I think a lot of companies now would say something like Slack is like their virtual office, where it's just like a chat room. I recently used a piece of software that creates a virtual office, and you just like move your avatar into a room to work with someone else. And I think people kind of laugh at it in the work context versus a gaming context. But there's something about using it that felt very natural. Why do you think we only see this like spatial thinking in the gaming world right now versus in the workplace or other areas of software?
I think this is due to the fact that people talk about interdisciplinarity all the time, but they don't practice it. You know, I highly doubt that there's any architect in the Slack design team, right? So I think there's a very important mission to create multidisciplinary teams that are going to be tackling multiple different aspects of an interactive environment. And I think it ranges from actual technical problems that relate to creating the software of that environment to the actual design of it, the hardware of it. So there are, I think, multiple ways in which that problem can be tackled. But I think the main fundamental problem is a cultural one. Everybody likes to exist in these silos. And the way our economy is structured doesn't allow for this kind of dynamic exchange, I would say, between designers and engineers, and every engineer wants to be a designer, every designer wants to be an engineer. It's this, I think this notion of this isolation really makes professionals look at other fields not only with caution, but also with a certain bizarre level of admiration, rather than just owning their own expertise and allowing a platform for people to create these kinds of platforms that you're talking about more collaboratively.
Thanks.
Right, thank you.
Thanks. If we could get David, Matt, and Sean for the lightning talks up. Thanks. Matt, if you're here.